user created data. Okay, so this is not a sample data. We created this data for our learning purpose so that it can be easy, and later on we can learn on how we can ingest data from various sources. Okay, from your local system, from internet, from remote servers, and all that. Okay, and we learned about a couple of commands here. Okay, so we practiced yesterday head, tail, sample, shape, column, data types, info, describe, and with a parameter passing on under describe to see the categorical data as well. Okay, and then we learned about how to write an inference. Okay, by seeing your data results. That also we learned yesterday. Okay, and we also learned on how to check the missing values. Okay, what is the command you will use is df. Df is your data frame, whatever the name you are giving for your variable, you can use that dot is null. Okay, and if you want to count how many missing values are there, you will use dot sum function. Okay, so this method, not function, sorry, uh, um, uh, okay. So dot sum function you will use along with is null. Okay, and then if you want to see a duplicated value, okay, to see if a name is repeated twice. Okay, so uh, how do you uh, uh, see if there is a duplicate value? Okay, you need to have something called a unique value. Okay, say for example, if you see uh, employees from any organization, right? You will have basically employee ID, right? Which is unique from employee to employee. Okay, so two employees cannot have a same employee ID or in school roll number, right? So each student will be assigned to a roll number, right? So similarly, when you are checking a duplicated value, so you have to see what is a unique column in your list. Okay, so if you see that unique column, and then if you can analyze your data, if there is a duplication, then you can correct it. Okay, and if you don't know, if you don't know how to check the values, then you have to create a uh, another column, okay, to make these entries do I mean unique. Okay, you can do that also. Okay, so you can use functions, okay, to create those. Okay, we'll see that later on when we are solving some problems, right, with a data set. Okay, so we learned about n unique. Okay, so you can see names, how many names are unique here? 20 different names. Okay, so if it is 1 means 19 are repeated. Okay, age is 7 are unique, sex 2. Okay, because in our data set we have two values, male, female. Okay, and marks 20. Okay, which is good because uniquely we took the marks. And study hours 11. Why 11? What happened to the other 9? Okay, those are repeated. Okay, so we have already done this yesterday, and then we learned about univariate. Okay, and how to uh, run the analysis on a single column. Okay, univariate means single column. Okay, so you can use value count, min max, mean, median, mode, describe. Okay, describe will give you a statistical imputation on your data set. Now categorical. Same thing, you can do the categorical if there are any, say for example, you have a country, okay, country list of 100 entries. Okay, I'll ask you how to count. What you'll do is you will say df in quote you will write the column name, which if it is a country you will write country, and value count. It will count all countries how many times they have repeated. Okay, so you have a Olympic data set and you want to see how many countries secured more than one, you can use the value count. Okay, so this is how you have to solve the puzzle here. Okay, and this is normalized type. Okay, I did yesterday this. Okay, right, I'll just run this. Okay, you can see one time is repeated. Okay, if it is two means two times Alok name is repeated. Okay, so since this is single, so there is no two times are repeated names, all unique. Okay, and this is about male and female count, how many times you are counting the value for male, okay, in a data set. Same thing you can count for a country. Okay, any categorical data you can value count, helps a lot. Okay, and this is for percentage. Okay, so I'm converting the data into percentage. Okay, normalizing, I'm doing a normalization of my data set, so which is 50-50%. You can see 10-10. What does that mean? Equal. I have a 20, and what is the percentage if I ask you? 50% male, 50% female. So that is where it is giving me 50%, 50%. If you want to convert your data, and bivariate, two columns, simple. Okay, two columns. You can compare two columns. Okay, two columns, and then if you want to see the mean, average, okay, and the sex and marks, okay, you can see female 89.6, male 71.9 is the average marks. Okay, so who is highest here? Female. Okay, so same thing, age and marks. You are comparing two columns here. Okay, this is the statistics number. Okay, average. Okay, so 20 hours, 21 hours, sorry, this is age and marks, sorry. Okay, this is age. 20 years guys are getting 88.5%. Okay, and then you have 21. Okay, now you see, as the age increases, the numbers decreases. So this is what you have to write the inference. Okay, and and this one is study hours, sex and study hours. Okay, do we have any relation between these two? Female is 17 and male is 10.5. Okay, so male guys are not interested. Okay, so on an average they are spending 10 hours. Okay, these are weekly statistics. Okay, weekly statistics, not daily. Daily you cannot do 10 hours, right? Week. So week stats is female are spending more time on their study hours. Okay, and that is where you can see the score also, right? And you can see older student between this age group have slightly lower marks than younger ones. You have to write an inference, proper inference, by seeing a data. Okay, so today we're going to see the correlation. Yes, correlation. So, oh no, sorry. Yeah, correlation only. Then we have outlier also. So first I'll start with correlation. Okay, correlation analysis. Okay, now what do you mean by correlation? Okay, you're correlating your data set. Okay, when I say data set, entire columns. Okay, you can also do the correlation with two columns, three columns also. Okay, so we'll just do the entire data set first, and then we can do the other part. Okay, and how do you do that? After your data frame, you have to write, 1 minute, why the drop down is not coming? Yeah, CORR. Okay, so this is the function correlation. Okay, the first one. Okay, and it's a function. So I'll open and close the braces, and then see correlation when you are doing. So the correlation is done between numeric and categorical. Okay, so sorry, describe is done for numeric only, but we are adding as include is equal to all, means it will include the categorical data as well, right? Now here what we're going to do is we will add correlation only for numeric value. Okay, numeric value is equals to, okay, correlation matrix. I'll just run it. Okay, now you see age, marks, and study hours. Okay, if you recall, uh, we can see these three. Okay, these uh, three columns we had seen yesterday, right? Sorry, numeric value. Sorry. Okay, if you see age, marks, and study year, these are in numeric value, and you can see the age value is 1. Okay, and you see the marks, it is going in negative. Okay, and you can see study hours is also going in negative. Okay, and when you compare with marks and age, you see this is going in negative, and marks positive, and study hours, marks and study hours, there is a relation. You can see 0.98%, there is a relationship. Okay, same thing here. Okay, now you see here age and marks. Okay, if you see age and marks, which is like 71%. Okay, 0.77. Okay, so age and marks. Okay, so I can say age versus marks. Okay, it is in negative point 0.7 1. Okay, because 7, so after 70 you see 7083 is here, so we can say 71%. Okay, now how do you infer this data? Okay, so you can say that by seeing the data, it indicates a strong negative correlation. Okay, negative, you can see a minus signature is there. Okay, minus sign is there, here, here, here. Okay, so you can say there is a strong negative correlation as age increases, marks tends to decrease. Okay, and if you see our data set, older students, okay, in our data sets are scoring few marks compared to younger ones. That is your first inference. Okay, I will write it down. Okay, first one. Okay, this data indicates about a strong negative correlation. Okay, as age increases, marks tends, sorry, tend to decrease. Okay, so this is my first inference. Okay, second inference would be, okay, I'll take age versus study hours. Okay, now there is a age and study hours, if you see 0.69. Okay, age and study hours, you see here 0.69, which is negative, which indicates, okay, again a strong negative correlation. Okay, for the see, this one is for age versus what is this, marks. Okay, I can say minus 0.71. Okay, okay, and this one is study hours and age. Okay, age versus study hours. Okay, now with this data, do you see any relation? You have to check the first one. Okay, do you see any relation? It is in negative. Now you have to write your summary. Okay, so you can say older student. Okay, older students study few hours than younger ones. Okay, simple. Okay, and this may also suggest that younger students are putting in more effort. Okay, that is what you can write. Okay, so this is the second inference, and now we will talk about marks and marks versus study hours. Okay, now you see your marks and study hours. Okay, this column, this one. Okay, this and study hours. Okay, so this and study hours. So I'll write it down example so that it will help you out. Okay, when you have other data, you know where to check what. Okay, I'll say marks versus study hours. Okay, third one I'll write inference as, okay, there is a strong strong positive, okay, there is a strong positive correlation. Okay, and then I can say student who are or who study more hours achieve higher marks. Study hours is most directly proportional to marks. Okay, students who study more hours achieve marks. Okay, so this is my inference for correlation. Okay, understood, guys? So you have to check marks and study hours. Okay, marks you cannot check. Okay, marks, age you can check. Okay, so you have to carefully see age you cannot see age and marks. Okay, So you can see as the age increases, the marks are decreasing in minus 71%. Okay, age in study hours. Okay, also you can see as the age increases, study also hours also is decreasing. Marks, age. Okay, so you can say same thing, minus marks and study hours. If the studies hours are more, you see a good result, which is 98%. Okay, study hours and marks 98%, study hours and age, okay, 69, and this is study hours. You cannot do the relation, you have to see the other one. Okay, so this is how you have to validate your uh, relation. Okay, now, okay, now see, you can see could not convert string to float. Amit. Okay, there is a name called Amit. First row. So correlation function doesn't understand how to convert array. So that is the reason why it will not work for non-numeric. Okay, it will work only for numeric. Okay, so you can do all these use cases. See, this I want to show you the error message. So it works only for numeric. Okay, inside you have to pass this parameter. If you have all categorical data in your data set, don't use this correlation. Simple. You cannot do anything. You have to convert those data set into a numeric number, which is called encoding, one hot encoding, or back propagation. We have a lot of models are there. Okay, you can use any of those models to convert your categorical data so that your Python can understand. Okay, Python cannot understand this categorical data, string data, and all. Okay, so they cannot interpret. So that is the reason we are getting this error message. Okay, so this is one. Okay, very important. Now correlation is done, so now we'll see at outlier. Okay, H outlier detection. Okay, okay, so first we'll understand what is this outlier. Okay, so why we have to do the detection. Okay, and when you do any analysis, right, it will definitely give you a wrong uh, inference. And if you take any decision making, right, based on this data where you are finding outliers, it will definitely give you a wrong decision making, and it will I mean, whatever the strategy that you are applying, okay, that will not be success. Okay, it will not be successful. Okay, so in simple term, if you ask me what is outlier detection, okay, I can say it is a process of identifying data points. Okay, now what do you mean by data points? I'll say df dot head. Okay, okay, now you see these are data set. Okay, now you have a age group, you have a marks, and you have a study hours. Okay, so now if you have this data, okay, we call this as data points. Okay, all these are called data points. Okay, so it's a process of identifying data points in a data set. Okay, you are finding a data points in your data set that elevates, or sorry, that deviates, okay, significantly from the majority of the data. Okay, now if you see here, okay, the age group. Okay, if I say dot head dot max. Okay, now you see who is the maximum number here. Study hours is 18, marks is 92, male, Sneha, age is 23. Okay, it should be female. Okay, so this is I added randomly male female, so maybe that's fine. Okay, this is just a sample data set. Now here I see a maximum of this and 23. Okay, so if I make it as 100 hours, okay, in a week, do you think that is reasonable? No, right? So that 100 number, that data point you see in study as is a outlier. Okay, you need to normalize that. Could be some mistake. Okay, whoever has shared that data with you, or whoever is working on data, could be a mistake. It happens, humans, right? So you have to correct that, or it is correct. Okay, so even if you work 12 hours, okay, so weekly it comes close to 72 hours. Okay, so which is not justifiable 100 hours, right? So 40 is reasonable, even if you are studying 8 hours per day. Okay, 8 5 are 40. Okay, leaving the weekends aside. So 40 is a reasonable number, but if you add 100, I don't think so. I mean, the student is sleeping only for 1 or 2 hours and is studying, which is not, uh, which is not a correct, information. Whoever has put that there. Okay, so what happens is when these extreme values, okay, these extreme values, whatever extreme values that you see in a data set, right? Then we call that as a outliers. Okay, and it can arise due to measurement errors, data entry mistakes, okay, natural variation it could be, or could be a rare events, okay, which will definitely influence on your statistics and data models. Okay, and that is why we say handling outliers is crucial for accurate data analysis, because okay, they can skew results. Okay, so if you have seen the bell curve, right? If your data points has some outliers, your data, the bell curve will be skewed. Okay, and which will definitely give you a wrong inference out of from, if you want to take a decision making. Okay, and what are the common methods that we have for identifying uh, outliers are box plot. One is box plot you can use. Okay, so and there are some common methods. Okay, statistical techniques are also there, like z-score method. Okay, and it's called the standard deviation method. Okay, and the interquartile range approach. Okay, so this is very famous. I'll show you this. Okay, and when you get some outliers, okay, outliers are sometimes removed or treated. Okay, removed and treated. See, for example, in this case, okay, in this case, say, just assume I have just 20 records here. You know, we have 20 records, right? So what if I have 10,000 records? Okay, 10,000 records, and there is one age of this person called Rohan. Age is 102. Okay, so could be a mistake, right? It could be an error, mistake. Okay, maybe some measurement error or data entry mistakes. Okay, and naturally variation can also happen. Okay, then what you can do is straight away this row, whatever the row that you see, okay, second one, okay, index, okay, you can directly remove it. Okay, otherwise if you all these data are normal uh, and just because of one entry your data is going for a toss. Okay, your analysis is going for a toss, you can remove it. 10,000 rows, one if you are eliminating, it will not make any difference, not even a point one. Okay, so that is where you have to take a decision making. Like I said, outlier detection is the process of identifying data points in your data sets, okay, that deviate significantly from the majority of the data. Okay, so these values are called outliers, and it can arise due to measurement errors, data entry mistakes. Okay, all this. Okay, and which will influence on your statistics and data models. Okay. Now, whatever data modeling that we are doing here through statistics, right? That is also one of the model, okay, that you are learning. Okay, so we'll practice this outlier detection. So this is just a sample data, and okay, I'll write down here. So in a see what we can do is we can see first I'll write down the code. Okay, so I'll say Q1 quartile 1. Q1 is equal to df okay marks. Okay, marks dot quantile. Okay, so I'll just type dot and tab. Let me see if I can get a quantile. QUA. Yeah, this is the one. Quantile. Okay, how much? 0.25. Okay, I'll explain this later. Okay, when we are going with what do you call advanced level, right? Data analysis. I'll explain why we have to take 0.25 or 0.75. Okay, if you see, if you recall in statistics, I'll just type it here only. Okay, you see here, I'll take the dot T transpose method. Okay, now you see I have a 25% quartile, 50% quartile, and 75. Okay, if your data points are not falling any of these, okay, it is going beyond. So those will be treated as outlier. This is one way, guys. Okay, so same thing 0.25 I'm taking here. I'll just take another data set. I'll say Q2 quartile 2 DF marks. Here I have to change to 0.75. Okay, 25 to 75. I'm just taking two quartile. Okay, so any data points that is falling between 0.25 to 75%, I am good. Okay, so we call this interquartile range. Okay, any data points that falls between 25 to 75, we call this interquartile range, IQR. We already covered in statistics. Okay, so IQR, how will you get? You will get, oh sorry, this is Q3. Okay, Q1 is this, Q3 is this is Q2. Okay, so IQR is equal to Q1, Q3. Okay, so I'll say Q3 minus where is Q1. Okay, and then I'll say I'll create one variable called outliers equals data frame inside I'll say df data frame marks. Okay, so I'm validating a marks is less than. Okay, where is less than, okay, less than q1 minus, okay, q1 minus 1.5 percent into IQR. Okay, what is our IQR? Q3 minus Q1. IQR. Okay, this is the first formula. I'll close this bracket and then I'll close the outer bracket also. Okay, this is for this, this is for this bracket. Okay, and then I want to write the same. 1 minute, guys. I want to write the same. Okay, this is, I'll write as pipe symbol. Okay, you know the pipe symbol means and. Okay, I'll copy this df marks is greater. Okay, this is less than. Now I'll write greater than. Here I have to use Q3. Okay, so here you see Q1, here Q3 minus 1.5 into IQR. Okay, and then I'll print the outliers. Okay, or you can say in print command. Okay, so let me run and see. Okay, now you see here how many entries are there? 20. Okay, so if you see here, all these entries, okay, are within that range. Okay, marks are within that range of IQR. Okay, even if you print this, uh, I'll write it down here. One. Okay, 17.75. Okay, so my IQR is 17.75. So what I'm doing is, so I am, 1 minute, Q1 minus, if you see this formula here, okay, Q1 minus, what is Q1? Q1, if you see here, Q1 is the marks within 25 percentile. Okay, so this number that you see, 21 and below marks, whatever the marks are there, that falls under 25%. Okay, and the marks you see 75, 23. Sorry, not that one. Sorry. We are doing the marks, not age. Sorry. Okay, 71% falls under 25% quartile. Okay, and you see here 89% falls under 75. Okay, now when you run this, right, you see these numbers. Okay, these numbers. Okay, and by seeing this number, okay, which are in range. Okay, you have 19, 20 rows, 20 rows are there. Okay, if there are any rows that are there, it will show up there. Okay, I'll just delete this. Okay, don't get confused. This is very easy. Statistics, if you have not following right now, please go through the statistics video that I have gone through. There I have mentioned this. Okay, so how will I write the inference now? INFR inferences. Okay, I'll write the inference. First one is there is no extreme. There is no extreme outliers in marks field. Okay. Second, I can say, and if you see the, let's see the study hours. Okay. So study hour, if you see 12, 15, 10, 18, 11, 16, 13, 17, 9, 19, 10. Okay. If you see the numbers, these are all distributed reasonably. Okay. So if you see here somewhere 200, then you say we are seeing outliers. Okay. So I can say study hours also funded distributed reasonably. Okay. So I can write these two inference for this. Okay. Now we will go with another one called feature engineering. Okay. Feature engineering. What is feature engineering? I'll just go through it. Okay. So yesterday I was telling about some calculation and all, right? So what I mean to say is, okay, uh, feature engineering, if you ask me, it's a process, okay, of selecting what are we selecting? Columns. Okay, selecting and transforming, okay, and creating a new feature from raw data. Okay, now whatever the data that you see, okay, these are the five columns we have. I need one more columns here. Okay, so that is called feature engineering. Okay, so in data science scientist language we call that as a feature engineering, where out of this marks, if you multiply marks into or age into or divide, you will get some output, right? Say for example, this is my sales data. Okay, this is my sales data. Okay, and just assume this marks number whatever you're seeing, this is the amount that I have spent to uh, build that product. Okay, and the selling price is this. Okay, just assume. Okay, now I want to see the margin, profit margin. What I have to do is I'll say this minus this, then I'll get my profit, right? So that is called, you are adding one more column here. You're adding one more column. Okay, and then you are doing some calculation there to bring that number out. Okay, so okay, so I can say here by seeing this data. Okay, now here age is there, marks is there, and study hours is there. You can see this person Amit, 12 hours he is spending and he secured 78. Now I can ask you one question. What is the marks that he is securing by studying per hour? Okay. Now you see you have a study hour and you have age and marks. Okay. If I ask you what is the per hour marks he is securing. Okay. So how will I do that? I'll write down the first, the business problem. Okay. So what is the marks per hour? I know this is the marks for 19 hours. Okay. But if you see 17 hours, 16 hours, 11 hours, okay, 18 hours, okay. So you see 91 and 93 for 18 hours and just 1 hour difference. But marks you should get 92 2, not 91. But if you want to calculate this, if you want to do the analysis, okay, marks per hour. Okay, now we'll add something called feature engineering. Okay, so how we gonna do? First, I will create one new column. Okay, so you can create new column like this. I'll say simple marks per hour. Okay, this is my new column. Okay, so right now how many columns we have? 3, 5. Okay, you will get one more here called marks per hour. That is what we're gonna do. Okay, equals. Okay, now what are the two parameters I have to take? I have to take df of marks. Okay, I'll take the marks divided by study hours. I use the division here, this mark. Okay, same that you use df of what? Study hours. Okay, and then I'll print the entire head. Okay, I'll say df dot head. Okay, we'll run this and we'll see. Okay, now you see, earlier we had just 5 columns. Now I have added one. This is called feature engineering. Okay, where you will look at your columns, and if you can bring out some analysis. This is the analysis I bought it. Okay, so marks per hour, simple. I divided marks divided by number of hours. So what is the per hour marks that we can see? Per candidate is 6 marks. Okay, per hour study is adding 6 marks. Simple analysis. Okay, we'll see some 10 rows. Okay, and then you can do the describe method also. RIB describe. Okay, now you see count is 20. Okay, so 20 rows are there, so it is calculated for 20. So what is the mean? 6 marks is the mean for all of them. Okay, what is the standard deviation? 0. 0.9. Okay, so from mean 0.9. Okay, it is not 9 point, 0.9. Okay, you have to see this decimal floating points. Minimum 4, maximum 8. Okay, and 25 percentile 5 marks. 50 bucket, you see 5 marks again, 5.9, 5.2, and then 75, 6.7. This is the analysis you can draw. Okay, this is one, and there was one more I was thinking. F dot group by function. Okay, GROUP group by. Okay, you have to supply one of by and level. Okay, we'll go through that also when we learn about data manipulation concepts, right? So you will be using this value count, group by, filter, query function, okay, to search uh, uh, data points from your data. Okay, clearly you can write a simple English statement just like how you write in ChatGPT, right? You write to get something, right? Similarly, you can do here also. There are some commands that you can utilize here. Okay, there is one more. I think sorting. Okay. sorting and filtering. Okay, so everybody knows what is sorting, right? Sorting and filtering. So you do that in Excel also, right? With your data set. Okay. So sorting in pandas, okay? In pandas is very powerful library. Okay. So in pandas, sorting is used for arranging the rows and columns, okay, in a data frame. Okay, so there is a method called sort underscore values. Like we have value count, right? Similarly, we have something called sort values, okay, which will sort rows by specific columns. You can specify ascending or descending order. Okay, sort on multiple columns. So you have those. So I'll just show one or two and then we will get going. Okay, what's the time? 32. Okay, I'll not take much time. I'll say df underscore sorted equals df dot. I'll use something called sort values. Okay, so this is a function. Whenever we say function, it will have uh, close braces, okay, bracket close. Okay, now the entire data, if I want to sort, okay, before this I want to present my data. Df dot add 20 rows. Okay, I want to see all 20 rows. So this is my data, all 20 rows. Okay, now if you see where is age, now you see age 20, 21, 22, again 20 is there, 23 is there, 21 is there. This is not properly sorted. Okay, so we can sort this ascending or descending. Okay, so first example I'll give you is within the bracket, it will take a parameter called by. Okay, and which column you want to sort? I'll say age. Okay, simple. Okay, and this is whatever the result that you have sorted, it is stored in df underscore sorted. Okay, you have to write it in a next line, df underscore sorted, okay, to print the display the results. Now you see age is sorted because I said by age. See, age is 20, 20, 20, 21 in order, 22, 23. See that? You do that, right? Proper order. Okay, this is one. Okay, and descending. Okay, let's see the descending. Okay, how will you pass those parameter? I'll take the same example. Okay, here I'll say underscore descending DSC. In short, I'll write DSC df dot sort value. Okay, here I'll take, instead of age I'll take marks. Okay, and then I'll put a comma. I'll say ascending, ascending, yeah, ascending equals false. Okay, if I think it's a caps, yeah, it should come like green. Okay, and then I want to display the result here in the next line, so I'll write it down here. Okay, so which one I picked up this time? Marks. Now you see marks descending, sorry, ascending. See, marks top numbers are there, 95, 93. Okay, so from higher to lower. Okay, this is how you can sort your data. And you can also say by mm, multiple columns. You can say the multiple columns also here. Okay. So I have here example by, you can see here by is equal to two columns, age and marks. Both are numeric, age and marks. Okay. You can also pass like this. You have one more column, put a comma, and third column. Ascending, true and false. See, why I'm writing true and false is true is for this age, false is for mark. Okay. I'll run this and you'll see. Okay. Now you see age and marks. Okay. Age and marks. Now you see age, I said ascending is equal to true, 20, 21, 23. So from lower to higher numbers it is going, and you see this stays as it is, 95, 92, 89, 78, 93. You see that difference here? This is how the Python will handle the entire um, this thing. Okay. Okay, guys, I think we are on top of the earth. We'll continue this filter tomorrow, okay, with some more examples because this is very huge sorting and filtering. We'll practice tomorrow again, okay. And what I'll do is I'll share this sheet tomorrow, okay. So tomorrow is Thursday. So after this is done, you can practice, okay. And I'll show you some more examples with box plot. Okay, so tomorrow I'll draw a box plot and then I'll show you the outliers. Okay, so different uh, concepts are there to identify outliers. Okay, this is one of them. Interquartile IQR, we say interquartile Q1, Q2. Okay, Q1 is 25%, Q3 is 75%, and Q2 is 50%. And if you want to see anything that is going beyond 50 means you have to say Q2 and 50%. Okay, so sometimes you will use all these things. Okay, when you bucket your numbers between these quartiles, right? You can easily identify whether it is correct. This is the formula, standard formula. Okay, Q1 minus 1.5. Okay, this is a standard formula that you'll find even in Google. I have already covered this in statistics, IQ or Asian IQ formula example. Okay, so IQ describes the middle 50 of value when ordered from lowest to highest. To find the interquartile range IQ, first median, mid value, and lower are upper. Okay, you have different ways to do that. Okay, so same thing we did here. Okay, and there are different formulas. That is one of them. By taking a 1.5 IQR Q3 minus Q, and if you go to some standard, how do you identify? See, once you start working with your data, right, you will understand. Just seeing it, you cannot understand here. Okay. See, what is the 1.5 IQR rule? Okay. If you see my where is my yeah, calculation here. So I'm adding Q3 minus 1.5 into IQR, the minus values that I'm getting for each and every points, data points. Okay. The commonly used rule says a data point is an outlier if it is more than 1.5 into IQR, above the third rule or below the first quartile. That is what it talks about. Okay. Lower outliers are below Q1 minus 1.5 into IQR. Higher outliers are, so outliers can be lower and higher also. Okay. For example, in our age here, we did it right. I'll not take much time here. Okay. For this one, if you see the age, okay. So if there is an outlier, okay. So you see the minimum age starts from 20. What if I have 9 or 6? Do you think that will add here age group? No, right? See, if you see all the age group, these are all mid-age, okay, or youngsters, okay, about 20 to 20, 30, between 28, okay, if you see the age. If you have a 9, 6, something, okay, so if that will fall under less low number, okay, that is what this formula says here, okay. Now I'll just add this. This is a very good point. I'll just add it here for your reference. Okay, I'll add it here. Okay, what is the rule? Okay, okay. I have to break this line, so I'll say BR and I'll give us some heading here H4 and I'll close this H4. Okay, close this, I'll run this. So what is the 1.5 IQR rule? Okay, this one 1.5. Okay, this is the explanation for it. I'll just save it. Tomorrow I'm gonna share it. Okay, so it will help you to find out if there are any data point which are lower than this number Q1, okay, and Q3. Okay, so we have only Q1 and Q3. Q2 is there, but if you know if your data point, see here we have only 20 rows. What if you have 100, 1000, 2000 rows? Okay, you cannot see, you cannot go all together, right? So that is where you will use this formula to, this is a very standard formula. This is very easy, guys. Okay, you have to keep all these data, I mean the templates somewhere. Okay, you have to take a copy of this template, and then here if you're working on some column, you have to change the column and get the outliers, look at those outliers, and then you have to give your inference. Okay, that is how everybody does. Chalo guys, we are top of the hour. I'll stop today. Tomorrow we'll do some basic